Before I dive right into defining the motion of a particle or a rigid body, I first want to quickly define those terms. A rigid body is a solid body that, when exposed to an external force, does not deform, or the deformation is so small that it can be neglected. In other words, when exposed to an external force, the distance between any 2 points on that body is constant. And the advantage of modeling objects in the real world as rigid bodies as opposed to deformable bodies is that with a rigid body, if I know the position of a single point on a rigid body in the world, as well as the orientation of that rigid body, then I know the position of every other point on that rigid body. Now, when I say particle, what I'm actually referring to is a mass particle, sometimes called a mass point or a point mass. And essentially what a particle is a zero-dimensional point that can be considered a rigid body whose size is ignored. In other words, the volume of that point is 0, but its mass cannot be ignored. So it's a body that has 0 volume, but it has mass. It just doesn't have a distribution of mass, whereas a rigid body has a distribution of mass.